Hello, bonjour, it's Laura here. In this video, I'm going to go through the problem-solving process of balancing an equation. Follow along and make sure you have a good eraser. So, you could have a question like this. Balance this chemical reaction. So, this is a chemical reaction here. This is the equation for it. So what we need to do is make sure that we have exactly the same number of elements on each side of the arrow. So we'll first look at the reactants. So the reactants are listed on the left of the arrow, and then we'll compare that to the products. Okay, so in the reactants, we have P, and we have 4 of them. So you can see this here, we've got phosphorus and there's 4 of them. That's the subscript. Then we also have fluorine, and we have 2 of them. Okay, I'm going to list the same elements but under the products. I like to list them in the same order, so the P and then the F, because then it's really easy for me to compare. Okay, so right now in the products I have a P, but I've got 1 of them. You can see that here. There's no subscript there. That means that there's 1. And then we have 3 fluorine. Okay, so is this equation balanced? The answer is no. I've got 2 fluorines in the reactants, 3 in the products, so that doesn't match. I've got 4 phosphorus in the reactants and only 1 in the products, so they do not match. So I do need to balance this equation. So what I can do is put numbers in front of any of these products and reactants and try to balance out the equation. Okay, now it's a little bit of trial and error with this as well, so like all chemistry, you need to have an eraser ready. You need to also give yourself some room. So let's see here. The best thing to do is start with the most complicated compound. So the most complicated compound in here is the PF3. So I'll try to balance that first. So I've got 3 fluorines. How could I balance the fluorines on both sides? When you've got some kind of, they're not awkward numbers, but I can't, if this fluorine in the reactants was a 6, then I could multiply the fluorine in the product by 2 to get 6, but that's not going to work. So what I could do is multiply the fluorine in the reactants by 3. That will give me 6 altogether here, and then multiply the PF3 by 2. That gives me 6 fluorines altogether. So my fluorines match now. What about my P's? So let's see here. I've got 2 phosphorus now, and in my products and in my reactants I've got 4. Okay, so what we've done here doesn't work. So we're going to need to erase those coefficients. And I've erased a little bit of my original question. This is why you need to give yourself a little bit of room. So I'm going to write that arrow smaller so I've got more room here to write my coefficient. Okay, so first try didn't work. Let's look at the P then, see if we can deal with it. So we've got 4 P's in the reactants, and we've only got, in the original question, 1. So what if I multiply the PF by 4? How would that work? Okay, so now I've got 4 phosphorus on both sides. How many fluorines do I have now in my products? I've got 4 times 3, so I've got 12 altogether here, and I'm going to cross out the 6. That try's done. What could I do in my reactant side to make sure that I've got the 12 fluorine? Okay, so if I multiply the F2 by 6, that's going to give me 12. Okay, so now I've got in my reactants 4 phosphorus, 12 fluorine. In the products, 4 phosphorus, 12 fluorine. So hooray, this equation is now balanced. So the true reaction is going to be 4 of these phosphorus plus 6 will react with 4 of the PF3. Good.